Today I would like to show you some of the capabilities of .NET custom templates, and I will actually try to focus more on kind of the coding part and create an application based on that and get it built and deployed with Azure DevOps out to Azure Kubernetes service. And even though those are the technologies we'll look into today, like AKS and Azure DevOps, you will see that .NET custom templates can be used anywhere. If you're using GitHub, you can use that there as well. So there are many capabilities that the templates can provide. But before we start out, so my name is Kristina Devochko. I'm from Oslo, Norway, and I'm working as a software architect. And apart from that, I also love contributing back to the tech community. I have my own tech blog, and I also volunteer both as a speaker and co-organizer in the tech community groups, and contribute to open source projects, and I work a lot with Kubernetes and containers and also getting .NET applications out containerized and hosted in Kubernetes and specifically AKS, so I really love talking about that. And on the personal side, I love animals, but they not always love me, as you can see in this picture. And I love cats, so you will see quite a few pictures of the cats, so embrace yourself. And I love hiking, puzzling, and playing some retro games on my spare time. So if we get to business, why am I here and want to talk about .NET custom templates? If you have seen, especially the last years, the pace that the technology is emerging at, the pace that the new versions of the tools, of the services are being released is quite high. And the expectations from the organizations and how often they deliver new functionality has also increased during the last years. The challenge with that is that the organizations can be at different levels of maturity, and they may have different budget, and they may have different amount of resources that can work on different parts of software development. And what this can often end up with is that developers may be expected to do a bit more than just focusing on the functional development or in the application itself. If the organization is smaller, they may not necessarily have dedicated resources that would be working with building pipelines for your microservices, to build them, to deploy them to Kubernetes. You may not have dedicated resources who will build container images for you or create templates that you would need in order to deploy those applications to Kubernetes. So this may end up in that developers may be expected to know and do much more and basically own the whole software development lifecycle, especially if you have teams owning their own microservices, for example, or their own applications. You may end up in a situation where you kind of need to figure out yourself how you need to get that application and that new functionality out in the end of that flow and make it available for the users. And you may have heard about it before, but lately there are a lot of talks about cognitive load on the developers. Due to this situation of that there are a lot of technologies, a lot of tools, and organizations may not necessarily be able to invest in, or it will not be worth the cost building some internal platforms that can make these things easier for the developers, then the cognitive load falls on the developers themselves and it becomes pretty high. And if you are a developer like me or many developers in my team, I guess what you would like to focus on the most part of your day is to focus on what you love most, and that is developing the functionality in the application and bringing the value in that application to the users and to the organization. And that's what you would like to do. And the level, like developers can of course be different, and some developers may be more interested into like learning a lot of different tools, getting out there, learn more about Kubernetes, about containers. I am one of such developers, but I also know that there are developers who love what they do and love their comfort zone, and they do not want to necessarily learn in depth the tools and platforms that they do not work with on a daily basis or that are not directly applicable to their role. So this is kind of what we started thinking in our organization as well, when we saw that developers got really frustrated and they felt it was hard to understand, okay, if I'm gonna, you just put that Kubernetes stuff on me, you put that Docker file, that container stuff on me, and I have deadlines, I have fixes to deliver, I have bugs to deliver, and then suddenly I need to know how do I handle this? How do I build a pipeline? No one helps me. So they wanted help and see how this can be done easier, how this can be fixed in a way for them. So what we have started looking into is how can we kind of avoid bringing more load on the developers so that their stack will overflow, and instead help developers get into that developer Zen state where they can focus on coding in peace, bringing that functionality to the applications, and then just focus on configuring, adjusting the configuration that they need for their specific application to be up and running, but the rest would be handled by them, will be generated by them, and all the best practices will be ingested in the background so that they can only handle kind of the aftermath and see if there are any improvements they need to do based on the output. And there are many tools out there that can help you, and the tool I would like to show today is .NET Custom Templates. And this is a pretty simple functionality, but we have seen that this can be extremely powerful once you start playing around with it and adjusting it to your own needs. So what are .NET Custom Templates? I guess most of you may have used a .NET New command when you need, for example, to create a console app or an ASP.NET Web API project. Then you could use some of the built-in templates that Microsoft provides once you install a .NET SDK, and then you run .NET New command with some parameters like the name of the project and all that. And the command outputs some initial folder structure, project files, solution file for you, so that you can start working on that project. What this also brings with it is that you can create your own custom templates and adjust them to your needs. And the template engine is open source, and you can also find it on GitHub and check it out. So I will share some of the resources afterwards. But what is cool about this as well is that you can create any types of templates. You don't need to create a .NET project with the templates. You can just create a collection of scripts that you want to be reused across teams. You can create a Python application template. You can create whatever you want, and this is also possible because the engine uses or is based upon something called runnable projects. So what this means is that whatever you create in the template is what you get on the output once you install it. So you can easily test it, you can easily adjust it to what you need, and this template engine will not be ingesting any specific tokens, will not do any transformation to the files or data that will not make it possible to test it and build it and run it directly. So you get what you create. And we will see that it makes it quite easily to maintain those templates as well, thanks to the runnable projects functionality. And there are also possibilities for the extensive configuration for the transformation you can do yourself, like excluding parts of the projects, transforming some of the data, generating some of the data based on the parameters that the users will provide upon installation. And there are also quite a few third-party custom templates available that you can find with .NET New search command. So here, for example, is a command where I search for the C# based custom templates with the name of identity server in them. And there are quite a few of those, and you can see that the authors are different and the amount of downloads is different. So this can also be beneficial. You can take a look at, has anyone created something that I am looking at, is this something that I can reuse and build upon to complete it for my purpose? So this is also worth checking out. That was all the theory. So now you are certified in .NET custom templating, and now we will get into the demo. So what I would like to show you today is how you would typically create a template collection where you not only create a single template but multiple templates, how you could configure those, how you could create a single NuGet package out of it that can be distributed at scale, how you can ensure that the changes are properly handled and versioned in those templates with a CI/CD approach, and we'll also create a new application based on the template and deploy it to Azure Kubernetes service. And we'll see if it fails. I hope not. I'm ready. I hope you are. So let's get to it. Here I have a .NET Templates demo repo that will also be available on GitHub afterwards, so you can go into it and check it out. And the first thing you would start with when you need to create .NET custom templates is to identify what do you actually want to generalize and make available for reusage. Of course, you would also need to be a bit pragmatic and ensure that you also reduce the amount of different fixes and commenting out, removing stuff for the developers. So it's important to think about what actually is worth to include in the template and not make it too overloaded. And once you have decided what you want to put in those templates, then you would typically create a templates folder. I would also recommend starting with creating everything set up for the template collection so that you can easily add a new template at a later point if you would need that. But of course, you also can have just a single template as well. But in this demo, I would like to show how you could create a collection of multiple templates. So once you have realized what you want to put in those templates, you create a common folder, templates folder, and you put all the source files, everything you want to be a part of that template in its dedicated folder. So under the templates folder here, I have two templates. The first one is called microservice-to-AKS web. So what this basically is, this is a bit adjusted, modified ASP.NET 7 web app application with Razor pages. So you can see it's ASP.NET 7. And in addition to kind of the basic code itself, it also includes a build pipeline, multi-staged build pipeline that has all both the build stage and the deployment stage included. It has some versioning with Git version in place to ensure that the application packages are properly versioned. It has a Docker file with the needed configuration to containerize the application, and it has a Helm chart that will allow to deploy that containerized application to Kubernetes. And here, only the fantasy sets the borders, or your goals set the borders of what you want to include in these templates. You can include the best practices, for example, if you want to ensure that you have some specific adjustment, that you have everyone has like logging properly configured, API versioning properly configured. You could add that into kind of the application code. If you want to ensure that you have proper security configured for the application that will be up and running in Kubernetes, you can also add it in the files in that template. You can provide examples with comments that can also serve as the documentation, so that when the developer wants to create a new app, they just deploy this template and they have all the information there available to make it work. And then they don't need to search in different places or try to go to different people to figure out what they need to include, to kind of start with as much best practices in place as possible. So here you kind of get to decide what you want to include in that template. So here it is a full-fledged .NET project, but another template I have here is to illustrate that it's also possible to include just a few files of different types. So here is a microservice security template. And what it basically contains, it contains a set of build tasks that can be ingested into an existing application and in an existing pipeline of that application that will run a set of security checks to ensure that the application is following security best practices for application development, and that, for example, there are no visible security holes. So you could just deploy that on top of an existing app. And the second step would be to let .NET SDK know that this is a .NET template. And you can do that by creating a .template.config file with a template JSON in it. And I'll not be going through every single property here because we'll then stay here until tomorrow. But the point is that this is the place where you will define how you want this template to behave and how it can be searched and found. So a few highlights of the configuration here is the schema. This is needed if you want to get IntelliSense and help through .NET SDK to kind of know what are the properties that are available so that you don't need to check documentation every single time. Then you have a set of properties that kind of, once you do .NET new list, for example, or .NET new search, you get information about the author, the tags of the template, and so on. Also, a few other highlights is the templates are based on placeholders, so this is something you would often use. And those placeholders will then be replaced based on the values that the user provides upon installation. For example, source name here represents the name of the application you want to create. So here I have microservice ASP.NET Web, and if you see here under the Helm folder, I have a folder that is called microservice ASP.NET Web. And once I run .NET new install and provide a name for the application I'm attempting to create, this will be replaced with the name I provided. So all this will be kind of handled for me, and the proper naming will be injected in this case. Also, I can let it know if I want a directory to be created for me where all the files will be put, or just put it out where it's being executed. And finally, kind of the symbols part is important because that's where you define which parameters you want the users to provide so that they can be executed upon. So for example, here I want the user to provide a solution name that is required and that it will rename all the files that have currently this name in place, and also the content of the files where this name is currently in place. So this is the default value, which also is a placeholder. So once the user provides another name for the solution name, it will replace it. So if you seen there in the source folder here, we had KTCU common microservice CS proi. So this would be replaced with the name you provide. And here, if you have you can also include unit test projects for your project. For example, you can include what you want, and this can be handled through the symbols. So if you have worked with ARM templates before, for example, this is like the variables that you would expect the users to provide. And you can do many more things than just the replacement. You can also have constraints. For example, that the template is only available for Linux operating system. Like if you have a Linux specific applications that you would like to create, or if it expects a specific version of .NET SDK, so you could include constraints. You could include modifiers, which we'll see afterwards. Like if you, for example, don't want a container, you don't want any Docker files, any Helm charts, you just want the application code to be provided, you could provide a switch or provide a parameter that I don't want that, and the modifiers will kind of exclude the files that are not needed in that case, and can change the content of some files that may be dependent upon those folders, so that users can decide for themselves what they want. And you have possibilities to also introduce custom operations and, for example, do something additional with regular expressions with automatic generation of specific values. That can be done and is not supported, for example, by the standard template engine. So you could adjust it to your needs. And also in this config folder, you can add localization if you want the template to be translated to different languages, so that if people in the other country where they have another language configured for .NET CLI, they can get this information in the other language. And you can also configure like how the command, the parameter short names and long names will be, because if you don't do that, then kind of Visual Studio generates it for you. And finally, you can even take it further. Since I have a Linux machine, I can't show you that, but with some additional configuration changes, you can also load these templates in Visual Studio. So when you do create new project, you get the list of different built-in projects available for you. But if you do some additional configuration here, you can actually get your templates also in that project list directly in the Visual Studio. And if you have an existing project that you want to convert to a template, you would just need to add the .template config file with template JSON in it. So you could use, if you have an existing project that would work as a template to be shared across, you could use that. And finally, the last step, to aggregate all these templates in a single package that we can use and distribute at scale through the NuGet feed. For example, we could create a CSPROI file. And here you could use like an NUSPEC format if you want to package it with NuGet.exe, but kind of the recommended and new approach to do that is to create a CSPROI file with package type template. Then the .NET CLI knows what it needs to do, that this is a .NET custom template. And then you need to provide some information about the package that will be available in the NuGet feed. You can also provide package version, but I will show you how you can do this outside of the project so that you don't hard code the version every single time, but it will be handled through the pipeline. And finally, a few other relevant properties is the target framework. Even though it does not build as a regular project per se, MS Build needs this information in order to be able to package the templates in a NuGet package. So you need to ensure that you are targeting the framework that actually you have available, so that MS Build will be able to handle that. And finally, you can add additional information about which content should not be included, like not include the binaries, the bin and object folders that are a result of building a project. And once you have done that, you're kind of ready to package it and publish it or distribute it. There are multiple ways you can do that. You can install it locally from a system path if you want to test it just locally. You can package or create a NuGet package locally as well with .NET Pack. But the good way to do it at scale is to create some kind of a CI/CD, some kind of pipeline where you can both version it, build it, test it, and upload it to a NuGet feed. So here I have a YAML file that is a build definition for Azure pipelines. And what basically is being done here is that versioning happens through the git version approach. So I don't need to define any versioning in the project file itself. I do some testing of the templates, which we'll get back to. And then I do the packaging of the template and pushing it to a NuGet feed. So if we go back to the Azure DevOps and open the NuGet feed here that I have available, you can see that here is my package with the .NET custom templates. On the right-hand side, I get some information about it, and I can see which versions are available and how I can download it. And the pipeline itself is available here, .NET templates build pipeline, which was tested quite a lot lately. So if you want, I can also share it afterwards on the GitHub repo, so you can also check it out for yourself and test it in Azure DevOps as well if you want. All right, then that was like the how you would create these templates. But now let's actually create an application from it. So first of all, we would need to install, if we do it the official way, to install that NuGet package. So what I can do is that I can say .NET new install, and then I have pre-configured the connection to my NuGet feed from before, so I only need to provide the package ID. As we have seen here, I just need to provide the name of my template package. And it will install the templates for me. And as you can see here, I get both templates already installed for me. So if I do, let's see if I can close this one and increase it a bit. If I say .NET new list, if I get a bit up, apart from the built-in default templates, you can see that I have the base template here. And how was the second called? Template for security scan of microservices is also available for me here. So now we can create an application. So based on the template. So as I said, I love cats, so the application will be about cats. But first we will start by just creating it from the template and see how it looks like before we add some custom code. So if I do .NET new and then the kind of the short name of the template, I think it was shall I say it was MSVC ASP.NET, MSVC ASP.NET, and then -h for help. I can get information about the available commands that I can provide, and as you can see, solution name is something that it was generated. The short name and the long name was generated by Visual Studio for me, so I can override that at a later point if I want. So if I say that I want this application to be called Cat Encyclopedia, because that's what it will be, and then I want the solution name to be called Cat Encyclopedia like this. And then I just do that, .NET new. And as you can see on the left-hand side here, a new folder popped up that has the proper naming how I want it to look like. And it has everything populated for me, and the Helm chart has also the proper naming. But we can also run it and see how it looks like once it has been created. So I can do .NET run -- project and then provide Cat Encyclopedia source like this. If it's fast enough, hopefully. All right, so we can just open it up and take a look at it. And it's very basic. It's very basic. There is nothing in it. There is some configuration mainly on the background, so we don't see much of the application itself here yet. But it works. So as I said, you can test it straight away. It's testable because this is a real-life project without anything custom being ingested. So if I was in the matrix, I could just download all this information into my head, but I am not, so I need to cheat. I have some files, some application code files that I have decided to create beforehand so that we don't use time on that. But before we do that, let's check in the initial code first so that we can see what changes are being added afterwards. All right, once it's checked in, let's copy some of the application-specific files into the source. So what we can see here now is that I have added some specific code that is related to my application. I have added some controllers, some modals. I have added some CSS styling to it, and then I also would like to change a pre-populated a file for me because I want to add an additional button here. So I will just use that and update that as well. Let's see. like this. And then we can rerun the project once again before we check that in. Come on. All right. So let's take a look at what application we expect to be hosted at AKS. And this is a cat encyclopedia application. What it basically does is that on every time you access it, it generates a random cat fact and a random picture of the cats. And if you want some additional cat love, you can just click that button and get it there. I loved cats, did I tell you that? So, it works. Nice. Then we are ready. We are actually ready to check that in. So let's do that. All right. Let's see. Add application code. Finally, the last thing we want to do is that we want to get the other template as well. We want the other checks, security checks, to be added as well. So now we have checked in the application code, everything is ready. The last thing we want to test before we start the build and deployment process is to get the other security.net template that we have created also ingested into this existing application. So if we take a look at .NET new, let's see, I need to remember how it was called. Yeah, .NET new MSVC sec, and then to remember the parameters, yes, I need to provide the name in case there are any placeholders that corresponds to the name of my application, and also -o is the output where I want these files to be added, and I want them to be added into the existing folder where my application resides. That's why I will need to provide it here as a destination. So once I do that, there are some more files that are being populated for me. So it created an additional folder where other build templates may reside, and one of them is the one that does the security checks, and it added some files that are needed by some of the security tools. One more thing that we need to remember to do is that I haven't mentioned previously is that in the build pipeline, in order for these security checks to be enforced, there is some documentation here available, and what needs to be added is already documented here. So I can just comment it out to inject that template into the build pipeline of the application and just add that. Adding security checks. And we are ready to start the process. So let's get back to the Azure DevOps page and to our repo. In this case, I'm using a mono repo where I have the .NET custom template collection and the application itself in the same repository. But of course, once you have the custom templates available as a NuGet package, it doesn't matter where you create applications. So you can have it in any other repos. But here you can see that we have a new folder that has everything we need for our application to run. A few things still need to be ready, which also can be automated, but this is kind of out of scope for this session. I have an AKS cluster running here, Chamber of Secrets, very secret cluster. And I also have Azure DevOps environment instance, which kind of will be the one handling the deployment of the application. So I have a target set here that this application will be deployed to AKS, and I have the pipeline that we will now trigger that points to that YAML file that was deployed by the template. So let's just run that pipeline. It will take a few minutes because it needs to go through all the steps, and we are also dependent on some DNS changes so that we can access this application through a public URL. So while it builds, I will show you a few other configuration capabilities that I mentioned before. So two things I would like to show, and one of them is how you can override the names of the parameters that the users will need to provide upon installation. So if we just clear this and do dotnet new ASP.NET Web once again, if that's the correct name. No, how was that? ASP. Yes. Yeah, so we've seen that this was generated by us, for us. So if we want to change that, we can create a new file under template config called dotnet cli.host.json. And then we can add some IntelliSense and the information to it. So first of all, we would add the schema that will help us get some IntelliSense out of it. And then under the symbol info section, we would need to provide what commands we want to change the names for. And this solution name must be equal to what is provided in the configuration file under symbols. So I have a solution name, which is a parameter, and this is equal to the solution name here, and here I can decide what the long name and short name can be. So to test this, we would need to uninstall KTCU, the template package that we downloaded from the NuGet feed. And was it incorrect? Shall we see? KTCU. Let's see. Oh, .NET, I forgot the new. .NET new uninstall. When you are using NuGet packages, you can also do .NET new update, which will then download the latest section of the template. But if you are installing the templates from the local files, you will not be able to do that. But at least you know that for the templates you use through the NuGet packages, .NET new update can also be used. So now if I would like to install the template from my local image, I could do .NET templates. I can provide the path to where the template config is available. So I can do like this. And it has installed from my local folder the template for me. So if I do now .NET new MSVC ASP.NET Web-H for help. What have I done again? ASP.NET. There you go. So I can see that the template options and the namings for them have changed according to what I have configured here. And the other thing that I wanted to show you, so what if you don't want to have the Docker stuff and Helm chart being provisioned for you, you just want to install the initial application code? Well, you could do that by introducing something called modifiers. So you would, in the template JSON file, create a new section called sources. Here we get help from IntelliSense. Not perfect, but some help at least. So it needs to be an array. And inside here, I'm a bit formatting stuff here. Inside here, we would need to introduce a property called modifiers. And inside this one, we will need to provide some information about what we want to change. So you would need to provide a, let's see, condition. Condition. So I want, if the user provides that use Docker is set to false, if the parameter is set to false, I would like to exclude a set of files. So here I would do like this. And I would like to exclude the Docker folder, and I would like to exclude the Helm folder when the template is being installed, because this is not something what the user wants. And then you can extend it further to, for example, not include, to modify the pipeline YAML file, for example, if there are some dependencies on these folders. And in order for this parameter to be available for others to modify, you would need to introduce a new symbol that is called use Docker. So this is what it's going to be called. And I will just copy this metadata because I'm lazy. Shall we see? Oh. Let's see. Yes, so this I tell the .NET JSON, I tell it that this use Docker is a parameter type of type Boolean, and provide some description and set it to be true. So by default, I want the Docker and Helm folders and everything related to that to be provisioned unless told otherwise. So now we can save that and do a reinstall of the template. And since this is a local installation, we cannot do .NET New Update, so we would need to do reinstall with force parameter. And now we can see that this it has been reinstalled. So if we take a look at what is available for us, we can see that we have a new parameter here. So if I say now that I want it to be a test app with, to see, SLN test app, and I want you use Docker to be false. What we can see here is that we also only have the source folder with the application code provisioned for us, but no Docker files, nothing else. And then we could work upon that. All right, let's see if our pipeline went through. It actually did, but I know it takes some time for the changes to take effect, so we'll see how ready we are. Not ready yet, so we'll give it a few more minutes. And while we do that, I want to share a few words on testing the templates. This is a good idea to test them, because if you need to make changes to them, you still need to ensure that they still work properly, and not wait until someone installs them and realizes that things need a lot of adjustment. And in the pipeline that you would need to create to kind of package and version those templates, you can add additional capabilities to it by introducing some test operations depending on what kind of templates you create. For example, many ways to implement it. As an example, I'm showing it as an inline script so that you can have directly in the pipeline, but you can also run it, you can also create scripts outside of it. And a few commands that I have here, for example, we just install those templates locally in a folder, and then it will attempt to build those templates just to ensure that they still work, they don't break. And I can, for example, run a set of linting on the Helm chart that will be used to deploy to Kubernetes to ensure that it is configured properly and properly formatted, and then you can extend it depending on what you actually want to test in those templates. So there is no silver bullet. You would need to adjust it according to what kind of template you have. And that's what we could also see here. Let me see if it came up. There you go. My app worked. So now it's actually hosted in Azure Kubernetes service. So it was deployed for us. So the only thing I did was actually just to introduce the application code. I didn't do much in the pipeline, anything much, and then it kind of worked. Of course, in the real life, that may be a bit more complicated than this application, but at least you can help a lot by getting some of these things out of the box for your developers. So if we take a look at this pipeline that was running for the application, it was not just building the app, it was running some security code scanning, it was running third-party package dependency checks. That this was implemented by me automatically in the template. It just knew what it needs to search for and scan it. So I don't need to remember about that. I don't need to go to the guidelines and check what I need to add or what I need a DevOps guy to add for me. I can, this is done, ingested in the application itself. The checks on the Docker file to ensure that it is properly configured, where the container images are uploaded, and so on and so forth. So many of these things were done for me, and I was only focusing on working on the functionality in the application itself. So if you have autonomous teams where you take responsibility of the full flow for a service or an app, this can be a good start. It cannot solve everything, but it can be a really good start and help for many who do not have a full stack competence in everything. And just to show you the testing step itself in the template build, we could also see it here that it did run quite a few checks with no problem. So if something was wrong, it would fail. All right, that was a lot of information, but if we try to sum it up, since we are getting closer to the end and the party. So now to add the last thing I would like to do is at least to make this presentation a little bit interesting. So what are the keywords or that can tell you how .NET custom templates could help? And I really miss the word art in the PowerPoint, as you can see. I had to find an external site to generate it for me. But what custom templates can help you is basically introduce reusability of some best practices, some coding guideline implementations that you want everyone to use. It helps you to create the whole flow for the application faster. It helps standardize and ensure that, for example, the applications follow the architectural design standards, that they follow the security standards that you have in the organization, and it is a way to enforce some of them automatically as well. It helps developers to focus on coding what they need and roll out the applications faster and simplify the parts that may be difficult or challenging or time-consuming for developers to set themselves into and learn by heart. So a few tips before we end up. If you start playing around with it, just start by creating a template collection so that you can easily add the templates as you go, so that you have everything set up correctly to do it at scale from the beginning. Don't forget to test those templates so that developers will not get back to you in the end nevertheless. Consider what's worth adding to those templates to minimize the amount of overflow of information in those templates as well, and to reduce the amount of things developers would need to remove or adjust. And do use template versioning and the NuGet feed, and also check the third-party community templates so that you don't need to reinvent the wheel, but build upon it and bring more values to the application. All the code, all the resources, the useful material that you can use to learn more about it, you can find in the GitHub repo where this QR code leads. And if you want to talk to me, I'm always happy to do that on anything .NET, containers, Kubernetes, especially AKS. So reach out to me. I'm always happy to help. So thank you.